In 1948, a man in Florida decided that the best way to survive a snake bite was to put snake venom into his own body before the snake ever got a chance. His name was Bill Host, and he began injecting himself with highly diluted cobra venom. Over the years, he added more species until he was eventually injecting a mixture containing more than 30 different venoms. He was bitten by venomous snakes roughly 172 times, with more than 20 of those bites reportedly coming close to killing him, especially in 1954 when a blue crate bit him. Host had assumed his resistance to cobra venom would protect him. It didn't. The venom eventually made him seriously ill, proving that becoming resistant to one snake's venom does not turn you into a universal snake-proof human. Somehow, Host lived to 100. And he wasn't the only person who believed venom could be used to make the human body stronger. Centuries earlier, there were reports of people in India deliberately swallowing snake venom in an attempt to build resistance to it. Which raises a strange question. If something can kill you when a snake injects it into your body, what actually happens when you drink it? And why does the answer have almost nothing to do with how poisonous the substance sounds? Before we find out, hit that like button and subscribe. Because what happens next is probably not what you think. Venom is not simply poison with better branding. A poison is generally harmful when it enters your body through ordinary routes, like eating it. Venom comes with a delivery system. A snake has fangs. A scorpion has a stinger. Certain animals have spines or specialized structures that inject their chemical weapons directly into another animal's tissues. And that distinction matters, because venom is designed to bypass some of the body's defenses. The snake isn't expecting you to politely swallow its venom and give your stomach time to inspect the ingredients. It is injecting the stuff directly into you, which is basically something like biological cheating. Now imagine the venom has made it into your mouth. It looks like the same substance that could put you in an ambulance after a snake bite. But the venom has just encountered its first problem: your digestive system. Many venom toxins are proteins and peptides, and your digestive tract is essentially a biological demolition site for proteins. Your stomach contains acid and digestive enzymes whose entire job is to break large biological molecules into smaller pieces. So a venom molecule that is extremely dangerous when it is delivered directly into your tissues may have a much harder time doing anything when it has to survive the journey through your stomach first. So for a moment, the situation looks almost absurd. The snake has spent millions of years developing a chemical weapon, and you have apparently defeated it with the world's least impressive superpower. Having a stomach but don't celebrate just yet because your mouth isn't an armored vault and your digestive tract isn't a perfectly sealed tube. If you have a cut, ulcer, or bleeding tissue in your mouth or throat, venom can potentially gain access to living tissue before digestion gets a chance to dismantle it. Suddenly, the question isn't simply, did you swallow venom? The real question is, did the venom find another way inside? The same substance that may be broken apart in your stomach can become dangerous if it gets access to the bloodstream through damaged tissue. And this explains why a snake needs fangs in the first place. Imagine two identical drops of venom. One is sitting in your stomach. The other has just been injected through a snake's fangs into your tissue. Chemically, they may contain many of the same molecules. Biologically, they are in completely different situations. The first has to survive digestion, cross barriers, enter circulation, and eventually reach a target. The second has already skipped several of those steps. Some venom toxins interfere with nerves and muscles. Others affect blood clotting or damaged tissue. Venom is not one generic poison. It is a complicated collection of molecules designed to interfere with specific biological systems. The snake's real trick isn't just making venom. It's putting the venom where it works. But there is another question. If the body can learn to fight venom, could Host's strange experiment actually work on purpose? The answer appears to be yes, at least to a degree. A recent study examining people who deliberately immunized themselves with snake venom found evidence of strong immune responses in some participants. The researchers found high levels of IgG antibodies against several tested venoms in some individuals, and their records included numerous venom exposures without antivenom treatment. They also found evidence suggesting that immune protection can sometimes cross over between related snakes, with stronger cross-reactivity within the same genus, but the study also recorded allergic reactions, infections, and other complications. This is not a DIY vaccination method. It is an extraordinarily dangerous practice that happens to reveal something fascinating about the immune system. And Bill Haast's story demonstrates exactly where that protection stops. He had developed resistance to the venoms he was repeatedly exposing himself to, particularly cobra venom. His own records describe most cobra bites as producing little more than local tissue damage once his resistance was established, but the blue crate was different. Haast initially believed his existing immunization would protect him, continued working after the bite, and only later became seriously affected by the venom. His body had learned one chemical language. The crate was speaking another. That is why immune to snake venom is misleading. There isn't one universal snake venom for your immune system to memorize. There are hundreds of different venom mixtures, containing different toxins in different combinations. And now we can make the question even stranger. What happens if the venom comes from a scorpion instead? A 2026 study tested the oral toxicity of venom from Heteroctinus junceus in mice. The researchers gave the mice oral doses as high as 2,000 milligrams per kilogram, and none of the animals died during the observation period. At the higher doses, however, the mice developed temporary problems including breathing difficulty, loss of coordination, and tremors, while the researchers also observed temporary effects involving the liver, lungs, and kidneys. The researchers concluded that this particular scorpion venom had relatively low toxicity when swallowed. Notice the important words, this particular venom, in mice, when swallowed. That is very different from saying scorpion venom is safe for humans. In fact, the researchers suggested that the digestive tract itself may help explain the result. The stomach and intestines are an aggressive environment for proteins and peptides, filled with acid and enzymes capable of breaking them apart. That means a venom molecule can be incredibly dangerous when it arrives in the body through a sting, but much less effective when it is forced through the digestive system. And this is what makes venom so fascinating. The deadliness of a venom doesn't exist independently of its delivery system. A snake can produce molecules capable of shutting down nerves, disrupting blood, or damaging tissue, but those molecules still have to reach the right place. A bite solves that problem instantly. Your stomach makes it much harder. And your immune system creates another layer of defense by learning to recognize certain venom molecules after repeated exposure. Bill Haast essentially spent decades teaching his immune system what certain snakes were carrying, but the blue crate demonstrated the limitation perfectly. Learn one venom well enough, and another snake can still walk into the exam with an entirely different question. So what actually happens if you drink venom? The answer is not, you definitely die, and it is not, your stomach makes venom harmless. It depends on the animal, the venom, the amount, and whether the venom can find a route into your tissues. Remember to subscribe and follow for more. Stay curious and take care.